So in previous lecture, we did talk about the independent t-test. And we have the assumptions one more time here. One of the one of the things that we mentioned also about the assumption number 4 and 5, and say if they are violated, then we are going to use the non-parametric test as Mann-Whitney test or Mann-Whitney U-test, the other name for this one. But what are the assumptions of the Mann-Whitney U-test? The first three assumptions are almost the same, only the assumption number 1, as you see, we can add if the dependent variable can be also ordinal, means a ranked variable. But there is another assumption which is important, assumption number 4 here become, and when the distribution of the scores for both groups of your independent variable are the same shape or a different shape. We should define if same or different. So here the shape of the distribution, it can be the same. In this case, we use actually Mann-Whitney to determine the difference in the medians of the groups. So you can use a box plot, for example, and then see if the box plot for the two categories are almost the same distributed. So you are using the Mann-Whitney, but at the same time, the importance of this one is for the null hypothesis, that you are in the null hypothesis, you say there is no difference between the medians. But if the shape are different, if you have, for example, box plots far from each other, the distribution, then you actually, by Mann-Whitney, determining the difference in the distribution. So as I said, the importance is in formulating the null hypothesis. Here you should explain that we find for example, the difference, significant difference in distribution of the two groups, not the median anymore. So let's see how we can do it with the same example that we had for fear of a statistic in day 1. By the way, this data, you can find it in the survival manual of SPSS, the book, and on the online you can find the files, and one of the files that you will find is also we are using this fear of a statistic. So if we want to do it, we do the analyze. We aware that we are doing a non-parametric test. So you are directly from analyze, go to the non-parametric test, parametric test. And here you have the legacy dialog, and then you use two independent sample. And then you will see this window that here you can also choose the test variable as we did before, and also the gender, and also define the group like we did in the independent t-test. And also if we are going to the option here, you will have this window and descriptive and quartiles you are going to choose, and the results will be something like this. And as you see, we have the first in the ranks, we have the male, female, and the mean rank here, and we are going to use this one. And also in the test statistic, you will have this table. The important thing about this table, we have two different answers here. Here we have a significant for asymptomatic and a significant for the exact value. Well, the asymptomatic, the first one, that's this one, p-value is good enough approximation to the real p-value when both groups have more than 20 cases. The SPSS give it to you when there is more than 20 cases for both groups, but for a smaller group's sample size, for a smaller sample size, SPSS calculate the second one, which is this one, and it's called also exact p-value, and the exact p-value as I said, it's shown only when the sample is less than 20 cases. And the p-value less than 0.05 or the significant means to accept the alternative hypothesis or reject the null hypothesis. And here, if we look at the mean rank also, we can use it and explain the result as a Mann-Whitney U-test used to determine the difference in fear of a statistic at first day between males and females, and distribution of the fear of a statistic scores for male and female were not similar. It means that you took a look at the box plots, and you explain here as assessed by the box plots, and you saw that there is a not similar distribution, and therefore when you are explaining this one, you actually explaining the what is statistically significant. And here it become the for example, fear of a statistic scores for male, and here you report the mean rank as you have here, and for male and female, and were not statistically significant different. And here, as you see, you are using the distribution because of the not the same distribution, so you are evaluating the distribution. In case if you had the same distribution or close to each other, instead of reporting distribution, you can report the difference between medians will be different. So here we are formulating the null hypothesis with medians. Here we are formulating the null hypothesis with the distribution.